Hello, my name is Marcel de Jong. I'm Technical Team Lead for M&E in North America, and I'd like to take you through this demo related to stand-ins. I call it Arnold Workflow 2. It's actually less of a workflow. It's probably more of a performance demo and therefore more suitable for things like pod demos at trade shows. But nonetheless, it can be very useful to show people the sheer volumes of geometry that Arnold can handle memory-wise and can render. With that, in order to talk about stand-ins, we have to talk about the AS file format. The .ass file format stands for Arnold Scene Source and is the Arnold native scene description file format. It's an ASCII file format by default, but you can turn on binary encoding, and through binary encoding you actually can use that to compress large arrays containing floats and components. And when you use it, when it's turned on and you output a .as file, it creates a more compact ASCII human readable file with binary components inside of it. But it leads to smaller files and faster load times, and especially when you're loading or copying lots of stand-ins that have to load lots of .as files, that can be useful. With that, it is very memory efficient in a number of ways, and one of those ways is as it relates to .tx textures. Whether you have your auto convert to .tx turned on, or whether you manually convert folders through the make tx manager to batch converting textures to .tx files. Either way, .tx textures are tiled, and the default there is 64 by 64 pixels. Arnold can load one tile at a time, and what it doesn't see, it doesn't load. In other words, things that are occluded literally don't load at render time, which is very optimized. You can also set a max texture memory limit, minimizing the amount of memory that's dedicated to that kind of work. Also, if you're using UDIMs, for example, a .tx is automatically generated for each of the subtiles as well, which is very nice. And then all of your .tx textures are also MIP mapped, so they're anti-aliased even at very low camera AA samples, which is really not possible for JPEGs, for example. All that and more. For example, stand-ins themselves. A stand-in is essentially a node you create in Maya that looks like a bounding box, and into that node you load a .ass file. Stand-ins themselves really keep things light in terms of the scenes for various reasons. One, they share memory footprint, and two, the actual loading of geometry and shading engine information don't really get loaded until render time. So it's a deferred loading of geometry and shading engine info until render time as well. So when the first ray hits the first stand-in, that's when it loads and that's when it starts to render. Now you do have some options inside of your stand-ins to view the content of a stand-in, the content of a .as file inside of your viewport as well. What's nice about stand-ins also is that it renders at full resolution. Whether it's your textures or your geometry, it renders at full res. So with that, let's move on to the second slide, which is a render of a stand-in of one of the Dreadnought's racers, and this particular one is about 10.4 million triangles. It's pretty dense, and I rendered it at 1920 by 1080. With a sampling, and those are the default sampling values, 3 for camera AA and then 2 for everything else. It took about 28 seconds to render, so it's quite fast, and you can see the quality is already fairly decent, right? There's still some grain and some noise, especially in the white, but 28 seconds is not really bad for that size render. So with that, this was a stand-in which I then copied in the X, Y, and Z direction 10 times to create 1,000 copies of a 10.4 million poly model. Then I exported that as a stand-in. So you can also export stand-ins from stand-ins, and then eventually I ended up with this, which I rendered also at 1920 by 1080 and dropped the sampling rates just a little bit. So I dropped it to 2 and then 1 for everything else. The number of copies of that jet, of that racer, the Dreadnought's racer, every little dot here is one of those racers. It was copied in X, Y, and Z 10 times, exported as a stand-in, brought in that new stand-in, that new AS file through a stand-in, copied it again, 10 by 10 by 10, and created the larger blocks. So So I went from 10.4 million to 10.4 billion to 10.4 trillion. And then I copied that 5 by 5 by 4 100 times to create a single quadrillion polygon block that I then copied to create a second one, effectively creating well over 2 quadrillion polygons. So if I were to actually drop the camera into the scene and right on top of one of these jets, I still get all the details in the cockpit, in the engines, and everywhere else. Textures, same thing. So what I'll start off with in Maya is the menus where you can actually export and import .as files from. So under File, it's just the standard menus, Export Selection, Export All. You can drop in here, there's an AS export. You can see that as soon as it's set to that option, you get a bunch of options to turn on or off, depending on what it is that you need in your .as file. You can also directly create references from .as files, so you can go in here and select the S format and create references in your scene using .as. Or you can go to the Arnold menu set, and under stand-in there is create and export. Export obviously is to create the .as file, and stand-in create is to create the stand-in that then allows you to load the .as file. So in this case, if we select the jet, we can go to Arnold, stand-in, export, open it up, and we get the same options. In here, if you're anticipating a very large .as file, you might want to consider turning on using gzip just to limit the size on disk. You can also turn on the export bounding box. By default, that's turned off. If you hit reset and we'll go to .as, you'll see that that is turned off. I like turning that on for the very simple reason that when you turn on the bounding box option here, it generates an extra file in addition to the .as. If you look at this, for example, env.as, there's also the env.as toc. So that file, that second file, is created as a result of turning this option on, and that helps you speed up things in terms of the redraw of all your stand-ins when you have very large volumes of stand-ins that you're duplicating. So I turned that on, and it makes a difference in terms of performance. The default option here that is turned on is use binary encoding. That is really used to compress large arrays. It's to create essentially a more compact ASCII. So it's still a human readable file with components inside that may be encoded binary. So that will essentially end up being a smaller file that loads faster, and so the benefits are obvious. So with this, I'm going to make sure that the racer is selected. I also want to turn on the engines. The engines are a part of that. If it's not visible, it doesn't get exported into the .as file, so I need to make sure that it's visible and selected. So the Dreadnought's racer will be exported. And as soon as I hit export selection, I'm going to save it over something called DNO1 high-res racer.as. Export selection will overwrite that. As soon as it is done writing to disk, it will return in my command line with the results. And so as soon as it does, there it is. I can then delete this from my scene, or I can start a new scene. Let's just start a new scene and load a stand-in. So create a stand-in, if you will. And with that, let's go ahead and open up the attribute editor and load that exact same file that we just wrote to disk, that .as file. There it is. So as soon as you do that, you should see the proportions of the bounding box change to whatever you exported. That kind of tells you that it's loaded. If you're not sure, you can always pick this and select one of the viewport draw modes from within the stand-in node. So if you want to, you can go into shaded, for example. Give it a second. It's going to update. Does not show you the textures, but it does give you a shaded preview of what's inside of that stand-in. That's not something you want to leave turned on if you're duplicating very large volumes of this. You can also set this to like a shaded poly wire. If we turn this off, you can see what that looks like. Because it's so dense, you can see that we get quite a bit of aliasing. You can turn on the anti-aliasing, which will work, but doesn't resolve all of it. You might want to go in here, set this to something like point cloud, so we can actually see through it, or just a wire, or we can set it back to bounding box. With this, I want to go ahead and illuminate this. So let's create a light. We'll create a physical sky. And with that physical sky, if I pick that physical sky, you can see it creates this black backdrop, which I don't really like because some of the stuff in my scene may disappear, may be hard to see. So you can just grab that physical sky, which is essentially a sky dome with a physical sky node associated or mapped to the color channel. but by selecting physical sky, you're shortcutting that. So with that selected, what I can do is down under viewport, I can set my sky radius to 0 so that I can see what I have in my scene here. So with this, let's go ahead and render this. Zoom out a little bit and frame this. So stand-ins render at full resolution, so it's essentially the same thing as what you exported initially, but it renders a lot faster. And this is what I'm rendering at, but it is at default sampling values of 3222222, and it is pretty much done already. It's just kind of cranking through here and doing the last bits and pieces of this jet. So let's go ahead and frame that. It took 19 seconds. So that's quite a bit faster than having to render the actual jet, the actual geometry, the actual source file. This is something that I want to replicate a very large number of times to get something that is very, very dense. This jet is 10.4 million triangles, and so we want to replicate this to the point where we get a ridiculous volume of triangles in the scene. So with this selected, what I'd like to do is just to start copying this, and let's move this over 10 times, for example. So here we got 3, 4, 5, 6, 7, 8, 9, 10. So now we're dealing with, let's call this 10 million per box. So this would be 100 million, and then we can duplicate this. 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be a billion. And then we're going to go ahead and do this again to go to 10 billion. So right now we got 6, 7, 8, 9, 10. So this would be 10 billion. This is 1,000 boxes, 1,000 jets. So let's go ahead times 10 million polys. So you can see that's quite a bit. And then if I wanted to render this real quick to get a sense of what this looks like, you can see that this renders just as quick as it did the original jet. What I can do to any of these stand-ins at this point is to say, okay, I'd like to maybe work with one of the stand-ins. Let's pick the one in the corner here and maybe render this. And then if you select the stand-in and go into render stats, you get a bunch of overrides that you can start to work with. So in this case, for example, if I wanted to turn off cast shadows, you can see it's no longer casting shadows onto the surrounding stand-ins. If I want double-sided to be turned off, if you look at the cockpit here, it's kind of muted and murky a little bit, and if I turn that off, it's now single layer. It should clear up compared to the ones next to it. We can also go in here, turn off maybe primary visibility. We just want to turn it off. You can see it's no longer rendering while all the other ones still render. So, there's a way to still manage individual stand-ins and how they affect the environment. So let's turn all this stuff back on. And what I'd like to do at this point is create another stand-in out of all these boxes, all these stand-ins here, by simply selecting them, going to Arnold, stand-in, export this. And we'll export this to the file called dno2 high-res-racer.ass, export, overwrite. And as soon as this comes back, we can delete all of what we have in here. We want to keep the sky dome in the scene, create another stand-in, and with that new stand-in, we'll load number 2. You can see that now we have a single box that contains 10 billion polys. And so now I'd like to go ahead and duplicate this as well. So it comes in at the size that I exported it as. So I'm going to scale this down a bit and maybe copy this another 10 times or so. So we got 3, 4, 5, 6, 7, 8, 9. One more, 10. And then we'll do the same thing in Y. So we have 4, 5, 6, 7, 8, 9, 10 times 10. This would be 1 trillion polys. And then I can duplicate this 10 times along the X direction. So let's call it 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. This would be 10 trillion polys for 100 million of these jets at 10 million polys each. We can do the same thing what we did before is we can grab this. This will be the last time I do this. Export this to DNO through high-res-racer.ass. Overwrite that. Get rid of all of this and bring this in one more time by going to stand-in, create, and load that third file there. So there we go. We already have the lights set up. Duplicate it 5 times this way, and then let's make that 5 times this way as well. So this is 25, and then this would duplicate 4 times. So that's 100 copies. Each of these boxes was 10 trillion polys, represents 10 trillion polys. So right now we should have 100 times 10 trillion would be 1 quadrillion polys in the scene that would render as soon as it starts building the image. And then if I wanted to just to kind of mimic what it is that I showed in the image earlier, if we were to go in here and do something like this, where we have that second set of boxes, and then maybe render this out, what we should get now is essentially well over 2 quadrillion polygons represented in a scene that has 200 million jets. Again, it's not really something that you want to do as a stage demo, but it's certainly useful when you want to impress people with what it is that Arnold is capable of processing. And so, 200 million jets, 2 quadrillion polygons, I don't think we've heard those numbers yet. That's it. Thank you very much.